There aren't many off-grid systems you can implement that can heat your home, produce your hot water, and generate electricity, all from a single setup. But this is one of them. And unlike a PV solar array, this is a system you can build, operate, and maintain with basic mechanical knowledge. And all it requires to run is a pile of wood. This is a gasifier, and it's a technology that was called upon in some of humanity's most difficult moments to keep industries running, vehicles moving, and homes lit. During the very periods when every conventional alternative had failed. Over the next few minutes, you'll discover how they work, why they're over 50% more efficient than traditional combustion alternatives, and more importantly, how you can implement them into your self-sufficient setup. To appreciate the power of the gasifier, we need to go back to a time before natural gas pipelines, to a world where smoke was becoming an extreme problem. In the late 18th century, cities grew, and coal burning for residential heating and industry accelerated. Major urban centers like London were already being plagued by the thick, choking pollution that came with it. So in 1792, a Scottish engineer named William Murdoch performed a series of controlled experiments in an attempt to fix this problem. He discovered that if he heated coal or wood in a closed vessel without oxygen, it wouldn't just burn. It would off-gas a flammable vapor that could be piped, controlled, and burned precisely where you needed it, while eliminating the thick smoke caused by incomplete combustion. Within 2 decades, the London and Westminster Gas Light and Coke Company had turned his lab-scale discovery into the world's first gas utility, piping town gas through the streets of London to light homes, streets, and businesses across the city. As the Industrial Revolution accelerated, gasification became the backbone of every major city in the industrialized world. And if you've already seen our video on the vehicle gasifier, then you'll already know how critical this technology became during the Great Wars. During World War I, severe gasoline shortages forced the adoption of town gas for vehicle propulsion, particularly in Britain, Germany, and France. Large gas bags were fitted to the roofs of cars and buses, a functional, if crude, solution. The limitation was energy density. Low pressure meant limited range, sometimes as little as 30 miles before the bags had to be refilled. By the Second World War, the world became reliant on gasifier vehicles once more, although this time the technology had improved significantly. The development of compact reactor designs, including the Imbert gasifier, made it possible to fit self-contained units directly to vehicles. At the height of the war, over 1 million cars, buses, tractors, and motorcycles were running on wood gas generated by onboard reactors. Entire agricultural and transport systems across occupied Europe operated on fuel produced from local timber or coal when every other option had been cut off. But after the war ended, and cheap oil flowed freely again, gasifier vehicles were abandoned. As for town gas, a major shift occurred in the early 20th century that also made it redundant. As massive deposits of natural methane were discovered underground, the energy industry began to phase out town gas in favor of natural gas, which was abundant, cheap, and safer. Now, before we get to how you can use a gasifier in your self-sufficient setup, you should understand why a gasifier outperforms a standard wood stove. You see, a gasifier is not a stove, but rather a chemical reactor. In a standard fire, you are witnessing combustion, the rapid oxidation of fuel in the presence of unlimited oxygen. But in a gasifier, you are performing pyrolysis and reduction. You are essentially starving the fire of oxygen to force the molecules to rearrange. The entire process operates through 4 distinct thermal zones. When wood enters a gasifier, the first thing the heat does is drive off moisture. This is the drying zone, where incoming heat removes surface and cellular water. It's important to get this right, as wood with a moisture content above 20% will quench the reaction downstream. Then comes the pyrolysis zone, where the temperature rises to between 752 and 1,292 degrees Fahrenheit. In the absence of oxygen, the wood cannot simply combust. Instead, it decomposes, releasing a mixture of charcoal, tars, and primary gases. The critical stage happens in the reduction zone. In a process known as the Boudouard reaction, the carbon dioxide produced in the hot core is forced through a bed of glowing red charcoal. This strips an oxygen atom from the CO2, turning it into carbon monoxide, and breaks down water vapor into hydrogen. The result is syngas, a mixture of hydrogen, carbon monoxide, and methane. It's a high-energy fuel that burns significantly cleaner than raw wood. And because you have stripped away the tars and the soot in the reactor, you are left with a gas that can be burned in a dedicated combustion chamber to heat water for a hydronic system, piped to a gas burner for cooking, or fed directly into a modified internal combustion engine to generate electricity. And the solid residue left in the reactor is biochar, a highly porous form of carbon that acts as a permanent habitat for soil microbes and holds onto nutrients that would otherwise wash away. According to studies conducted by the Cornell University Department of Crop and Soil Sciences, biochar is one of the most powerful soil amendments on Earth. And the efficiency of these systems significantly outperforms traditional combustion systems. In 2024, researchers studying decentralized thermochemical systems found that a small-scale downdraft gasifier could achieve an overall thermal efficiency of over 80%. Significantly higher than the 30 to 40% efficiency of a traditional open fireplace, while releasing up to 90% less particulate matter. And the impact this has on fuel economy is huge. According to research from All Power Labs, 2.2 pounds of dry biomass yields approximately 88 cubic feet of syngas. For a homeowner with access to timber, a single cord of wood, roughly 128 cubic feet, contains enough stored chemical energy to provide months of cooking and supplemental heating. And for those conscious about reducing their energy footprint, a study by the Rice University Baker Institute for Public Policy confirmed that gasification is one of the few technologies that can be carbon negative. The biochar produced in the reactor is essentially pure carbon pulled from the atmosphere by the tree. And because that carbon is then buried in the soil rather than burned into the air, the system removes more carbon dioxide from the atmosphere than it produces. This has a massively positive impact on the habitat in direct contact with the material. Research cited by the USDA Forest Service found that biochar increases soil water holding capacity by up to 28.5% and reduces nutrient leaching by up to 28%, keeping nitrogen and phosphorus accessible to crops that would otherwise lose them to runoff. When managed on a sustainable feedstock cycle, gasification can lock away between 50 and 80% of the feedstock carbon in a stable form that persists in the soil for centuries. So plenty of data and real-world examples prove that gasifiers offer energy independence in an accessible and non-destructive manner. Yet there are several reasons why it is unlikely gasifiers will ever reach their wartime level of popularity again. And the most obvious is the supply issue. A wood gasifier requires a sustained, significant supply of dry biomass. To meet the full heating, hot water, and power needs of an average American household, you are not talking about a few bags of wood chips from a garden center. You are talking about a continuous supply measured in multiple cords per year, which means either access to a commercial biomass supplier or, for those pursuing genuine self-sufficiency, land. Now, every time we cover biomass-based solutions, the question of deforestation comes up, and it is an important one. But sourcing a gasifier's fuel supply does not require clearing ancient woodland. Coppicing is a woodland management technique with documented use stretching back at least 10,000 years across Europe and Asia. The practice involves cutting back species, like hazel, oak, ash, and willow, to their base or stool at ground level. And, because the root structure is already fully established, the regrowth is often faster and more energetically dense than the original. Cut the stool on a rotation of 7 to 15 years, depending on the species, and it will produce harvestable wood indefinitely, without killing the tree, without clearing the land, and without reducing the woodland's carbon stock over time. Traditional managed coppices in England have been harvested continuously for over 500 years from the same stools. And because coppicing allows light to reach the woodland floor, it supports significantly higher species diversity than an unmanaged closed canopy forest. But for those without access to land, the technology remains viable for supplemental heating and cooking using sustainably sourced wood pellets or locally sourced cordwood, though both the economics and the self-sufficiency case are weaker. The second barrier to gasifier tech is the convenience, or lack of it, with these systems. A mains connection to the natural gas grid delivers heat at the flip of a switch, A gasifier, on the other hand, requires that fuel be cut and dried in advance. And while it produces very little ash compared to a conventional stove, the ash pit still needs to be monitored. If the grate gets clogged, the airflow stops, and the chemistry fails. This is not a passive system. The third barrier is the one most homeowners never get past, and that is bureaucracy. Both the National Fire Protection Association and the local building code office lock gasifiers out of the American suburb, a combination of uniform mechanical codes and utility protectionism, on the assumption that any unvented gas production is a lethal hazard. In reality, a gasifier is a negative pressure system. Because the gas is being pulled through the reactor by the vacuum of the burner or the engine, any leak in the system would simply pull air in, rather than letting gas out. It is inherently safer than a pressurized natural gas line that can fill a house with explosive vapor from a single hairline crack. So, if you have the means of a regular supply and the motivation to manage a gasifier system, then there are various options available depending on your ability and technical requirements. For those looking for high-efficiency home heating in America, the easiest entry point is the wood gasification boiler. Unlike a standard wood stove, these units have two chambers. The top chamber gasifies the wood, and the bottom chamber burns the syngas at temperatures exceeding 1,832 degrees Fahrenheit. This is a great move for anyone with a large woodlot. While the upfront cost of a certified unit is between $4,000 and $7,000, the efficiency is so high that it typically pays for itself in wood savings in less than 5 years. But for viewers in Europe looking for the highest available performance in a living room unit, the Waltherm Vaugelet range represents the current standard. These are precision-engineered gasification systems for domestic use. By using a downdraft combustion process, the Vaugelet pulls the wood gas through a glowing bed of coals and into a second combustion chamber, where it is mixed with preheated air, achieving a 93% efficiency rating, the highest ever recorded for a wood-burning appliance. And for the homesteader looking for electrical generation alongside heating, a downdraft gasifier feeding a modified internal combustion engine is the established path. Using a series of stainless steel vessels, often repurposed from beer kegs or heavy-gauge pipe, you can build a reactor that feeds directly into a standard gasoline generator. The technical specifications for this build are documented in detail in Ben Peterson's Wood Gasifier Builder's Bible or Stephen Honkus Wood Gasifier Builder's Workshop. Purpose-built automated kits are also available from companies like All Power Labs for those who want a factory-engineered system. For those who have access to a sustainable fuel source and know how to implement such a system, the home gasifier has the potential to generate a self-regulating stream of power without the need for the grid, the utility company, or the succession of failure that defines our modern energy dependence. In this video, we mostly covered the gasifier in the home environment, but if you want to learn more about how gasifiers kept vehicles running when gasoline disappeared, then take a watch of that video next.